I'm here today to talk about introducing and scaling a GraphQL BFF. So we're going to be talking about growing an API like a plant, growing an API in production over the course of a few years, specifically a GraphQL API. And I'm going to tell you the story of a GraphQL API that I built at Condé Nast and basically what happened to it over the course of 2 years and where the architecture is going. And I wanted to talk about this because GraphQL has been around for a few years now, but it's only really just hitting the big time now. But there are people and companies that have been using it for over a year at this point and might be looking to scale their architecture beyond a certain point. And there are also still people who are looking to introduce GraphQL. So hopefully this can satisfy all of these people. So this is what I'm going to talk about. I'm going to give a quick 1-minute crash course on what GraphQL is, just in case you need to know. I'm going to talk about BFFs, not best friends forever, the backend for front-end software pattern. We're going to talk about that, what it is. I'm going to talk about building and scaling a BFF and what we learned on this whole process. And this is a photo of me, as you can see. If you want to, I'm a software engineer at Condé Nast, which is a publishing company in London. And if you want to tweet me, it's Ms. Michelle Gar. You can tweet me about GraphQL anytime. But let's do our GraphQL crash course. This is a JavaScript meetup, and GraphQL is not a JavaScript specific thing. It can be used in many languages, but there are a lot of JavaScript enthusiasts of GraphQL. How many people here have used GraphQL? Okay, solid. What about people who are GraphQL curious? Yeah? Good, okay. All right, here's our crash course. What is GraphQL? So the official GraphQL website will tell you that it is a query language for APIs. You also might say that it is a language for requesting remote data. And when you hear it spoken about, you'll probably hear it spoken about as the cool new alternative to REST APIs, the new way that APIs are being built. And let's do a quick comparison of REST and GraphQL. I will say REST is fine. They're not mutually exclusive. You can use both. You don't have to change your whole life to GraphQL unless you want to. So with REST, you will often have multiple endpoints. So for example, if it's a publishing website's API, you might have an article endpoint and a video endpoint. The article endpoint will give you article data. The video endpoint will give you video data. GraphQL has a single endpoint that can provide all data. So it's one multi-purpose endpoint. It's usually /GraphQL. And with a REST API, you get the same set of fields from the endpoint every single time. So even if you only need the title, if you go to the article endpoint, you'll always get the exact same set of information about that article, regardless of how much of that data you actually use. In GraphQL, you specify what specific fields you want, and then you get exactly the data you asked for, no more and no less. And the key concepts in GraphQL, there is a schema that tells you what fields you can request from the API. And then you write a GraphQL query that describes the data fields that you want. And so you get back exactly the data that you ask for in your GraphQL query. It's kind of like a shopping list for API fields. So BFFs. Let's talk about BFFs. BFF stands for the backend for front-end API. Which is a software pattern that was originally popularized by SoundCloud a few years ago. And it's a pattern that's specifically for internal organization APIs, by which I mean APIs that are not widely available for public consumption, but internal to one particular organization. And let's talk about what this is offering an alternative to. So the alternative, or what existed before this pattern, is the one-size-fits-all API. And this is an API that's a monolithic API that is shared between multiple applications or front ends. It probably wraps the main data sources that are used by a particular organization, like the common database, something like that. And you might have a scenario like this, where you have the shared API and it's being consumed by multiple applications. And these applications might have different user experiences, and they might use different parts of that shared API. But because this API is shared, this API must serve all of those UIs and applications equally. It's a common denominator between all of the different platforms. So it's not necessarily a bad idea to have a common shared API. It happens frequently. But there are some common pain points that occur with a one-size-fits-all API architecture. The first one being that different clients need different sets of data. So it's impossible for one API to have the perfect endpoint for every single application, giving it exactly the article data that it needs. And if the one-size-fits-all API tries to do this, it will probably become really bloated. The article endpoint will have thousands of fields, talking from personal experience here. And it's going to become increasingly unruly. And the second thing is that the shared API becomes a bottleneck when rolling out new features. So say there's a new feature, and the UI developer, the front-end developer, they need to put in a feature request to the back-end team or the API team saying, hey, I need this new set of data. And they're unable to proceed until that feature request has gone through. And meanwhile, the back-end team, they have to juggle the priorities of multiple different applications, which means that your feature request might not always be at the top of the pile. So this is where the back-end for front-end pattern comes in. So it's in order to solve the pain points of having multiple applications, putting a burden on one single fits-all API, the BFF pattern recommends building one API service per user experience or front end. So that means that each front end essentially has its own custom API that is built specifically to serve the needs of that user experience. And crucially, it's maintained by the same team that builds the front end. So it might look like this. So a BFF is created as a sort of translation layer in between a shared API or data source, which means each application can specifically tailor the API for their own needs. Clients might also be using multiple APIs, so more than just that one particular shared data source. So a BFF API can act as a sort of single application API gateway, which aggregates all of the different APIs into a single backend for front-end API. So let's talk the benefits. Number one is that it's easier to adapt the API as UI requirements change. So now, if a new feature requirement comes in or a feature has to change, instead of waiting for the backend team to do all the work to implement that data set, they can just go ahead and implement that themselves in the BFF. Secondly, it simplifies the process of lining up client and server releases. So now that one team is managing both the UI and the API, they don't have to release it exactly the same time. Also, because it's focused, the BFF API will inevitably be smaller than a shared single-purpose API. It'll probably have smaller payloads. You're not getting unnecessary data. And finally, you're able to aggregate multiple calls to downstream services into a single interface that is used by that UI, which is a lot simpler and probably, in most cases, more performant. So if you're a GraphQL enthusiast, you might be thinking, BFFs and GraphQL, they might have some crossover, some similar benefits, in which case you would be correct. Because the BFF pattern was created before GraphQL became popular. And the BFF pattern and GraphQL do solve many of the same problems. So if we do a comparison, BFFs provide only the data that is needed by the client because it's specific for that UI. And meanwhile, GraphQL allows clients the flexibility to define their own data needs so they can specify exactly what data they want. BFFs reduce overfetching because they return only the data for one client rather than multiple clients. And GraphQL does the same thing since it's returning only the data that is requested. Finally, BFFs allow you to combine multiple data sources into a single BFF interface. And GraphQL also allows you to aggregate multiple data sources into a single GraphQL schema or interface. So there's definitely a lot of shared ground between BFFs and GraphQL, but they're definitely not equivalent to one another. Backend for frontend is a design pattern that can be used with any kind of API, a REST API or a GraphQL API. And GraphQL APIs are not always designed to be BFFs. Sometimes they are designed for multiple applications rather than just a single application. But the reason that I'm talking about BFFs and GraphQL together is that in my experience, BFFs are a very common way to introduce GraphQL inside organizations. And I'm not just saying that because I built one, but I have heard many stories of this being the case. And I've heard of many teams introducing GraphQL to their company or project in the form of a BFF that will frequently wrap legacy APIs. It'll frequently aggregate multiple data sources, ease a transition to microservices, or be a bridge when there's a migration between different APIs. And my theory on why GraphQL BFFs are so common is that I think that a BFF is a really low-stakes way to introduce GraphQL to an organization, especially when GraphQL was not as popular as it is now. Its surface area is limited to a single application, and it does not require you to actually rewrite any downstream services in GraphQL. So now I'm going to tell you about a real-life GraphQL BFF that I built and what happened to it. But first, some context. I work for Condé Nast, which is a publishing company. Lots of people haven't heard of the parent company, but have probably heard of the brands such as Vogue magazine and GQ magazine, which are the two brands that I work on. And I always say this when I give GraphQL talks, but GQ is not a magazine about GraphQL. It is a magazine about men's fashion. Just want to make that clear. Although I would read that. So for 3 years, I've been on the team that builds the international Vogue and GQ websites. So currently, my team is responsible for 21 different international Vogue and GQ websites, and they're all served by a single platform. So it's a multi-tenant React application. And these sites are currently fully powered by GraphQL. All of their data needs are served by GraphQL, and they have been since early 2018, which is when we made the switch to GraphQL. And you might have seen one of these before, a content management system, specifically a custom content management system. This is where all the data comes from for the Vogue and GQ websites. It's an internally built CMS. And so this is where the data comes from for our React application. And Copilot has a REST API. It did not have a GraphQL API when we first started building with it. And we're very dependent on this API. So before we had GraphQL, our API architecture looked a bit like this. So we have a React application. It's a very simplified version of our architecture. You see React application, and we were speaking pretty much directly to multiple REST APIs, the most significant being the content API for that CMS Copilot. And here are some of the problems we had. So the REST API that we used was not intuitive. Some of the fields were named kind of weird things. Some of the data took multiple requests to get. Some of the data was really deeply nested in ways that did not really make sense to us. So that was the first problem. Secondly, we were massively overfetching data. There was just so much data when you get a single article. And a lot of this was making its way to the client. So we just had way too much data. And finally, our React components were littered with so much API-related business logic because we were speaking to the REST APIs pretty much directly from the REST application, the React application. So early last year, we introduced GraphQL in the form of a BFF. So you see, this is our architecture, and we're still speaking to the exact same REST APIs, but we introduced this GraphQL BFF in the middle as a sort of common interface or a shield that sits in between the React application and the REST APIs, providing a single interface that the React application now queries. So all of that business logic that was previously in the React application has now moved into this GraphQL BFF layer. And it took us about 3 months to fully switch over to GraphQL. Most of that was taken up by writing acceptance tests. We integrated our new API incrementally, so we did it page by page. We started with a category page, and then finally did releases week by week until we made it to the home page. And here's what GraphQL gave us. A beautiful, intuitively designed API that actually made sense to us, with relationships designed in a way that made sense to us. It gave us the ability to fetch only the data that we actually needed, rather than a lot of unnecessary data. It gave us a single interface to interact with multiple downstream services. And finally, it kept our components free of API-related business logic that was previously cluttering up the application. And honestly, we just loved GraphQL. We all were obsessed with GraphQL. And it was a really successful development in our architecture that made everyone working in the application super happy. New developers who joined the code base were thrilled to work with GraphQL. But for now, this API was just being used by our single application. And we'd created our own personal GraphQL schema wrapping APIs that were used by other teams. And just to foreshadow the next bit of my talk, we did always have a slight feeling as we were building our GraphQL BFF that perhaps someday this schema would be useful beyond the confines of just our application, and maybe we could share it someday with other teams in the organization. And I'm going to stop here and talk about one of the issues with BFFs, which is duplication, which is something that comes up a lot. And in the scenario that I've just described, there's already some risk of duplication because we're essentially re-implementing a common shared API. And if another application or another team decides to wrap the exact same API, which did happen, then their code would look pretty similar to ours. And I think that as developers, we are naturally adverse to duplication. We're obsessed with making things super dry and getting rid of duplication. And so for many of us, BFFs will feel really counterintuitive because duplication is really inherent to the pattern. So Sam Newman wrote the iconic blog post about BFFs. If you Google backend for frontend pattern, it's the first result. And he said, one of the concerns of having a single BFF per user interface is that you can end up with lots of duplication between the BFFs themselves. They may end up performing the same types of aggregation or have the same or similar code for interfacing with downstream services. Some people react to this by wanting to merge these back together and have a general purpose aggregating edge API service, but this model has proven time and time again to lead to highly bloated code with multiple concerns squashed together. Damning review. And the next quote, which I love, is duplication is cheaper than the wrong abstraction. So this is a quote from a developer called Sandy Metz. And I really love this quote, and I think about it all the time when I write code. And I really believe that when we design code and services, you should always start from a place of duplication wherever possible, and optimize later down the line once you actually have validated the need for a particular abstraction and can see that it is the right one. So I'm talking about this philosophy of duplication and abstraction because ultimately we did go on to create an abstraction to try and fix some of the duplication that was inherent to our BFF. But I don't suggest you do this without really questioning first if your abstraction is really necessary or if it is the right one. So don't build a shared microservice before you know that you actually need this shared microservice or it is the correct microservice. So let's talk about our BFF version 2. So early last year, the question came up of what to do with our GraphQL API and what the next step in our architecture was. And we'd been using our API in production for about a year. And here are the numbers. So we're serving 21 different websites with this API, so Vogues and GQs in 10 different countries. And we have about 200 million users each month across all of these websites, which is a pretty big number. And I should think about that when I deploy my code. So our API is doing well. It's managing to serve the needs of this many users and applications, but we felt the need to scale. And one of the reasons that we felt the need to scale is, first of all, when we built our GraphQL API in 2018, we were kind of like rebels. It was cool it was bleeding edge. Even just 2 years ago, GraphQL was not as popular as it is now. And what we were doing was considered experimental within the organization, and people were quite suspicious of it. And we really had to we had to fight against the perception that we were just introducing GraphQL for vanity reasons that didn't actually provide technical value. And we really, we had to prove that what we were doing was legit. But now in 2020, it's a very different world for GraphQL. It's taken off. Usage of GraphQL skyrocketed, and we started hearing from other teams at Condé Nast that they also wanted to build a GraphQL API, possibly wrapping the exact same API that we had already wrapped. So yeah, people were very interested in GraphQL. So we'd wrapped this REST API in GraphQL. We'd designed schema that we really loved and enjoyed using just for ourselves. But yeah, we discovered that other people wanted the same API wrapped in GraphQL. And there was even one team that did wrap it in GraphQL. And looking at their schema was a very eerie experience because it was very similar to ours. And so with this in mind, it became time to think seriously about abstracting out that commonality between the different teams and build a shared microservice, which is when we introduced this architecture. So we decided to split our BFF API into two. So first of all, there's the core content API. So it's the REST API that we had originally wrapped for ourselves, but now made available for other teams and applications to use. But we did still feel that there was a need for the BFF. So because the BFF, it represents data more than just content. So we also had integrations with third-party APIs. We had a configuration API. There's a bunch of other stuff in that BFF. And so the core content API cannot single-handedly represent all the data needs of our application. So we decided to keep the BFF for now. And here's what so this is what our architecture looked like before we split out the content API. So you see we have the GraphQL BFF. And here's the change that took place. So we created this GraphQL content API that wraps the REST content API. And the GraphQL BFF speaks to this GraphQL content API. That GraphQL microservice can now be used by other applications in place of the REST API. So the content management system can now be considered to have an officially published GraphQL API that anyone can use, which was not the case 3 years ago. And a big part of the dream of this architecture is that we would be consuming GraphQL all the way down. So instead of carrying the complexity of wrapping the REST content API inside our BFF, we've delegated that responsibility elsewhere. And so this new GraphQL microservice, building it was a challenge all of its own, and I was on the team that was building this new microservice. And I have to say, as a developer, it's quite rare that you're given the opportunity to really improve upon something that you've built and make it available for other people. And the challenge this time around was to ensure that the schema that we had built just for our application would be generic enough to be used by other applications and teams. And although this schema is representing pretty much the same data as the first time around, we now have the license to make improvements with hindsight in mind. So because we have hindsight, we can ultimately build a better API. So the final challenge was to integrate this BFF, integrate this new GraphQL microservice into our BFF. And as a reminder, this is what our new architecture looks like. And here's what we need in order to integrate with this new microservice. we need a way to forward or proxy content queries through to our new content API via the BFF. And we also need the ability to integrate with the new content API incrementally, because we need to support a production application throughout the entire process and not break 21 websites, ideally. And there are a couple of options for getting GraphQL microservices to speak to each other. The first talk mentioned Apollo Federation, which is the cool new way to have GraphQL microservices. So we looked at the different options, and Apollo Federation, we weren't quite ready for it. It would take a bit of an architectural shift for us. I won't go into all the details. If you're interested, come and talk to me. But ultimately what we went with was schema delegation, which essentially allows you to create a reference to a remote schema, so a schema which lives somewhere else, and get that schema to resolve queries for you for a part of your schema. So you see we have the BFF schema, and any queries to the content schema get delegated and resolved by the content GraphQL microservice. So this approach was a little messy. Schema delegation is not the ideal solution, but we really wanted a way to get up and running quickly and a way to make incremental change and possibly replace it with something better like Apollo Federation later down the line. And the result of all of this is that we have a Vogue article which looks exactly the same. Wow. But little do you know that beneath the surface, the data is now coming from a different place. And the readers might not appreciate this while they're catching up on the German Fashion Week news. But behind the scenes, developers are much happier because they don't have to deal with the complexity that was being carried in that BFF. And also, maybe now that they don't have to maintain that GraphQL schema, maybe they will have more time to work on those features that they would actually see and would actually make an impact on their lives. The caveat is that this is still in progress. So the perfect fantasy is not quite here yet, including the additional time to work on new feature requests. So the process of migrating to this new content API is currently underway. But in the meantime, and this is quite cool to see, several other teams within the organization have adopted the new GraphQL API and are starting to use it in production. So there are now 3 different teams using the API, which is quite cool. So beyond MVP, so thinking back to what I said earlier about GraphQL and BFFs, here's what I think now about GraphQL and BFFs. So GraphQL is not a like-for-like replacement for a BFF, but I think that it solves enough of the same problems that if you evolve your architecture towards consuming purely GraphQL microservices, you might find that you no longer need a BFF. And with that in mind, personally, I'd really love to see our organization's API architecture move towards more of a gateway model, which is ultimately where the industry is leading, as we saw in the first talk. So I'd like to get to a point where we could remove the existing BFF and speak directly to a Condé Nast organization-wide GraphQL gateway that is backed by GraphQL microservices. So I don't want to rush the process like this turtle. I want to be thoughtful about how we scale our architecture and not create abstractions too soon. And what did I learn? First of all, focus on incremental change. You might dream of having an amazing GraphQL gateway of microservices to start with, but unfortunately, if you're evolving the architecture of a production application, that's not always where you can start. And if you build something for too long in isolation, you might build the wrong thing. So try and build things incrementally. Think about smaller areas of the schema that you can optimize or pull out as a microservice before you pull out everything. And as the first talk also said, don't optimize too early. So we could have built a generic API to start with, but we didn't. And I think that we ultimately built a better generic API because of this, because we had a year of product learnings that could actually make it better. And that is the end. Thank you.